So hi there, my name is Charles Tilburg, and I could not be more excited about how many people are here. I also want everyone to know here that there is an overflow room, and so we have even more that are in this room. So I am so excited that we have this many people interested in climate change and solutions to climate change. So I'm just overjoyed. Now I'll actually do what I'm supposed to be doing and read this, but I just wanted to start with that. So I want to welcome everyone to the University of New England's Spring Sustainability Lecture and Solve Climate by 2030 event. So my name is Charles Tilburg, and I'm the Academic Director of the School of Marine and Environmental Programs here at the University of New England. And I want to start with saying that I think it is actually extremely difficult to overstate the threat of climate change to the planet and its inhabitants. Humans' continued emission of fossil fuels has altered our climate, damaged our shorelines, resulted in the extinction of species, affected our ability to feed ourselves, and caused some spots on Earth to simply become inhabitable. Uninhabitable, yes. Yes. Glad we can inject a little bit of humor in this. Now, while this may be alarmist, I want to say that our future is not bleak. And the fact that everyone is here is one of the reasons why I feel that it's not bleak. People like you and me are making progress in addressing this threat. Our universities and colleges are conducting research on new ways to both study and address climate change, as well as educating students and providing them with the very tools to continue the fight. So as a climate scientist, events like this give me hope that we are going to be able to address this existential crisis. So at this time, I'd like to show a brief introductory video to emphasize the University of New England's shared mission with hundreds of other colleges, universities, to focus attention on climate solutions. Lee?
Economics, literature, math, engineering, history, music.
What meaning do they hold if our climate swallows us whole?
I can be courageous.
I can be
courageous.
I can use my voice and passion, keep fighting even on the days it feels hopeless.
I can fight for my people.
I can hold on to the beauty we still have.
I can save our land against this man-made havoc.
I can be a voice for the sky, the soil, and the sea.
I can make a good future for our next generation.
I can stand up even when it feels easier to sit down.
I can love my brothers and sisters and protect their lives because we have the same mother, the great Mother Earth.
I can be louder than polluters that try to silence life.
I can do my part and lead others around me to do better.
You are joining tens of thousands of students at hundreds of schools across the planet in learning and thinking about the work each of you can do now and in your future to repair the climate and lead a just transition to a clean energy future.
So in a few minutes, we'll be hearing from Dr. Cameron Wake, Director of UNE North, the Center for North Atlantic Studies. First, however, it's my pleasure to introduce the 6th President of the University of New England, Dr. James Herbert. I got to say a couple nice things about you first, James. Since assuming the UNE helm in 2017, President Herbert has overseen the creation and implementation of UNE's current strategic plan, Our World, Our Future. And he's led the university in making a number of important investments in its programs and students. He's led the effort to decarbonize UNE's investment portfolio and has overseen our progress towards being carbon neutral by 2040. He's shown himself to be a friend and ally of the environment who is always ready for a conversation about the future of our planet and what role that UNE can play in that future. So please join me in welcoming President Herbert.
Thanks, buddy. Thanks, Charles. I appreciate that lovely introduction. It's nice to see this is great, seeing so many people. I love this. It just shows the commitment and the interest that people have in this topic, so that's fantastic. I want to express, first of all, my sincere appreciation not only to Charles, but to Bethany Woodward and to Alethea Caridi for their help in setting up today's event. Can we give it up for Alethea and Bethany? So, thank you. So it's my pleasure to join you all and Dr. Cameron Wake, who I'll introduce in just a few minutes, for this latest example of UNE's commitment to research, education, planetary health, and leadership in the North Atlantic region. Specifically, this event focuses on mitigating the impacts of climate change, arguably the premier planetary health challenge in not only today, but all of human history. This event also marks two important occasions. First, it signals the return of a pre-COVID tradition at UNE of honoring leaders in the sustainability movement and giving them a forum to share their ideas. This tradition began in the Department of Environmental Studies and now carries on in the School of Marine and Environmental Programs. Second, today's event contributes to UNE's participation in the worldwide project Solve Climate by 2030. During the first half of April, thousands of universities in more than 100 countries around the world are holding educational events similar to this one as part of a coordinated effort to empower meaningful, locally oriented, and fair solutions to climate change. The goal is not just to address climate change, but to begin to do so within this current decade. We chose Dr. Cameron Wake to be our speaker for this larger effort to honor his contributions to climate change research and education, both globally and locally, and to celebrate his appointment as director of UNE North, the Center for North Atlantic Studies at the University of New England. Dr. Wake assumed the leadership of UNE North in June of 2023, last year, after 35 years directing an interdisciplinary research program focusing on studying regional climate change, engaging in partners in the sciences and solutions related to climate change, and developing sustainability education and research opportunities for his students. His previous appointment at the University of New Hampshire was as the Josephine A. Lamprey Professor of Climate Sustainability. While at UNH, Cameron worked with UNE on our effort to become members of the University of the Arctic Consortium, and he serves now as UNE's representative to the University of the Arctic. You may recall that UNH was one of the universities that partnered with UNE when we hosted the U-Arctic Assembly on our Portland campus in June of 2022. So over his career, Cameron has also amassed an extremely impressive resume of highly impactful research with experiences ranging from the recovery and analysis of ice cores from the Arctic and Himalayan regions to the study of how climate and land cover changes, affect key ecosystems right here in New England. He's the author of more than 90 published papers in peer-reviewed scientific journals and more than 30 reports. He's provided hundreds of interviews for state, regional, and national media, and has testified on the topic of regional climate change before the U.S. House of Representatives. His collaborative research on regional climate assessments in the Northeast has been covered widely in the media and has been cited as motivation for policy action. As director of UNE North, Cameron leads a center that connects and engages researchers, educators, students, policymakers, and industry leaders from across the North Atlantic and Arctic regions. These various stakeholders work together to build and sustain healthy communities, environments, and thriving economies. UNE North is central to our UNE mission of supporting the health of the world's peoples, communities, and our shared natural environment, and Cameron is exactly the right type of person to lead it. We're lucky to have him as part of the UNE community. Today, he will present a lecture titled The Climate Crisis, Science and Sustainable Solutions. So please join me in welcoming Dr. Cameron Wake.
Thank you, James. I want to start today by really expressing my deep gratitude to the University of New England community. I have been welcomed here with open arms, and for everybody that I've worked with, I really appreciate it. I've been here 10 months now, and dare I say, I think as of today, like it feels like home. So thank you everybody. Climate changes. It always has and always will. The only difference today is that humans are the main drivers of that change. And once you accept that, once you understand that, the following is true. The future climate is literally in our hands. The climate that our children, grandchildren, great-grandchildren, and their children inherit depends fundamentally on the decisions we make now and over the next few years on how we produce and how we use energy. So that brings me to the framing for the talk today, right? The bad news is we have burned our way into a climate crisis. That burning of fossil fuel has provided us with a luxury in our lives that was unimaginable 150 years ago. But it comes with a byproduct. And when you burn fossil fuel, you get energy, but you get carbon dioxide, and it's warming our planet. So the flip side of that is the good news. We've created the problem, so we can actually solve the problem if we decide to. We have the technology at hand to solve it. What we really need now is the political will. And if there's one thread that combines, that brings together all of my comments today, it's that we're all in this together, and we all need to act. Everybody here in the room, everybody at University of New England, everybody in Maine, everybody in the United States, everybody across the globe. We have waited too long to act for us to sort of have partial measures now. We really need to be all in. And my hope is that we can actually, in the process of addressing climate change, is that we can also transition to a more just and equitable society. And for me, that's what the sustainability framework really provides. I do need to talk a little bit about UNE North. It's good marketing, it's a good audience. James has sort of shared with you what our mission is. It's really about connecting the UNE community, students, faculty, staff, researchers, with our external partners, right, to build and sustain healthy communities, healthy environments, and thriving economies by fostering innovative and sustainable solutions. And I really see there's three key pillars for UNE North. One is the pursuit of sustainability. I'm going to talk more about that. Interdisciplinary is really important to me. We can't solve the problems by staying in our disciplinary lanes. We need to figure out how to work together across disciplines. And right in line with the tagline at UNE, right, we have to innovate in the way that we're going to address a whole set of grand challenges, including climate change. Why focus on the Arctic and the North Atlantic? Well, the reason is because it is a part of the globe that is warming 3 to 4 times faster than any other part of the globe, in part because we're melting lots of sea ice and exposing lots of dark ocean. So I just want to share a couple of sort of important climate change records that have come out of the Arctic. This represents monthly Arctic sea ice for the month of September, so the end of the melt season. Record starts in 1979 when we first sent satellites up into space to monitor it. And you can see we've gone from about like close to 8 million square kilometers of sea ice at the end of the summer melt season down to almost 4 million square kilometers. So we've reduced it by about 45%, 10% per year. Why do you care? Because Arctic sea ice is white and it reflects incoming solar radiation. When you remove it, you expose the dark ocean, which absorbs more incoming solar radiation, causing the system to a vicious cycle that actually ends up melting more sea ice and exposing more ocean and melting more sea ice. So if you have a look at that next picture, you can see that yellow thin line represents the average sea ice extent for the last 30 years, and then the 2023 minimum in white, which occurred on September 19th. You can see huge areas of the Arctic ice pack have now disappeared. And we've likely passed that tipping point. I'll talk more about that later on. I also wanted to share this figure from Jill Pelto. I am by training a scientist. I will always be a scientist. I talk to people's heads and minds more than their hearts. And I just think that there's a real call for more art to help sway people. And I really love this image by Jill Pelto. You can see it's the same Arctic sea ice record, the big decline, those really big declines in 2007 and 2012. But what she's chosen to highlight here and which really dominates the image are these Arctic foxes. And the way she's drawn them is they're trapped, right, in this reducing sea ice. We're reducing the extent of their ecological range. And they're frightened and they're scared. And it brings sort of a different perspective. I know polar bears have been sort of iconic for climate change. in the Arctic, but I really think sort of this Arctic fox figure captures it for me. I kind of made friends with an Arctic fox in the penny ice cap, but that's a different story. Here's the climate record that like nobody has heard of, but is taking the scientific world by storm, and it's temperatures in the North Atlantic Ocean. So you see here over the course, we've got 1981 to 2024. All those gray lines are the temperatures each year. There's a dashed line in the middle, that is the 1982 to 2011 mean. There's the dashed lines on the outside, which are 2 standard deviations about the mean. And then you can see 2023, we are totally outside of the range of normal temperatures, right? Not by a little bit, by a degree to a degree and a half Celsius warmer across the entire North Atlantic. And this isn't like a 1 month or a 2 month feature, right? This has now gone on for more than a year. Why is it happening? Well, El Nino is a little bit of the cause. Global warming is a little bit of the cause. Probably a reduction in the amount of sulfur that ships are emitting are part of the cause. And perhaps a reduction in the dust coming off the Sahara. But we can't really explain it all. It is one of those surprises in the Earth's climate system that we're going to spend a lot of time trying to figure out. And that those of us that study climate change are the most worried about are these tipping points in the system. And that just gives you a sense of the overall warming. That's the North Atlantic. You can see, you all know, I'm sure, that the Gulf of Maine is one of the most rapidly warming bodies of ocean in the world. All right. How many of you today have a cell phone with you? All right, of course you all have a cell phone. So we're going to do a little exercise, a little public participation. What I want you to do is get out your phones, and I want you to think about what your answer to this question. What is sustainability? So you can either go to this webpage, that's polev.com, CW, my initials, Cameron Wake, CW 2024, that's the year we're in. If you want to text, you can send CW 2024, your message to 22333, or as some of you are already doing, you can just nail that QR code up there. All right, so my question is, what is sustainability? What does sustainability mean to you? In your answer, we're gonna build a word cloud together. In your answer, if you want to use 2 words, make sure you connect them. There's no spaces. You can put a dash. If you say something, you can just run it all together, but don't put any spaces because that will represent 2 different responses. So I all want you to just take the time to respond now. I'm hoping the responses are going to come in. This is my little experiment. I've never done this before. What is sustain? Oh, the website is polev, polev.com/CW 2024. Excellent. See, it's working. All right. Reduce capitalist expansion, clean energy, longevity, reuse, reduce, recycle. Excellent. Keep those answers coming. Survival, renewable, excellent, long-term. Life essential. The bigger the words, the more responses, right? So renewables is a common theme here. Keep your answers coming. For now and the next generation, absolutely. Essential. Compromise. Justice, very good. Equity. Just transition. Regenerative. Long-term. All right, this is fantastic. I just want to say, you guys did way better. Can I say this, James? You guys did way better than the Board of Trustees did. But I didn't have this really cool tool then. So thank you for that. All right. So you get a sense of sustainability really is about, I want to say it's about more than survival, but survival is important. It's about food. It's about justice. It's about equity, it's about renewable energy, that's good. So I now have another question for you, which is, what sustains you? What gets you out of bed in the morning? What is it that really motivates you to go to school and to learn more and to try and make a difference? What sustains you? So same webpage, same text. All right. Brownies, absolutely. Nature, fish, my passions, the gym, dogs, the ocean, place. I said nature already. Making a difference, preventing the climate crisis, sushi. All right, we've clearly got an ocean crowd here. Forests, dogs. Dogs are getting bigger. My wife's here today. I'm sure she texted dogs. Forest. Oh, there's my favorite one, upper left-hand corner. We're getting to the root of it, love. All right, so the difference in the way you answered these two questions is really important. When I ask you about what sustainability is, it's academic. When I ask you what sustains you, it's personal. And what sustainability is to me and what sustainability should be is the personal. It's not about surviving. Sustainability is about thriving. It's about love and relationships and education and actually, following your passions, making a difference, having purpose. So when people talk about sustainability, it's certainly not like about the environment. It involves the environment, but it's not solely about the environment. It's about us. And that's what your responses are showing me here, right? Is that it's about coffee and a whole bunch of other really important things. All right. Thank you, Lee. Next slide. One of the framings for sustainability that I think is a really nice frame are the Sustainable Development Goals. These were developed by the United Nations, and they were adopted by all the countries of the United Nations in 2015. And they really provide a roadmap for prosperity and peace for the Earth, in addition to addressing a whole bunch of other grand challenges. There's 17 of these sustainability goals. You can probably already figured out that my favorite is number 13, right? Action on climate. What's really important about all of these is that they are all connected. While you can work in different aspects of the challenge is all connected. So as I've been working on climate action for more than 3 decades, right, I've fundamentally connected it to life below water and life on land, right? So this is part of key components of the Earth system. But I've also connected it now to no poverty, right? It's really hard to think about how we address the climate crisis and make it a just transition if we don't address big challenges of poverty. Quality education has been something that I've dedicated my life's work to. You can see number 5, right? Gender equality. This is such a huge challenge that we need everybody on board to address it, not just, right, the men or not just the women. We need all of us together. Affordable and clean energy, obviously a fundamental part of climate action. Sustainable cities and communities, really important because that's where more and more people are living and more people are going to live in the future. I noticed capitalism came up as one of the topics, right? This responsible consumption and production, really important. So the Sustainable Development Goals are a really nice roadmap, and what happens is you start working on one and you end up making the connections to working on lots of others. I also wanted to define this sustainability in a couple of different ways. One, academic definition right here. Systems and processes that operate and persist on their own over long periods of time. So a systems approach to sustainability is really important. So we're not reductionist when we think about sustainability, right? We step back and we look at the big picture. And then sustainability always is about time. It's always about future generations. And I would add it's always about place, right? So sustainability here in Biddeford or here in Maine is likely different than what sustainability might be in Arizona or in Mexico or in South Africa or in southern India. Here's a pretty traditional definition of sustainability, but I continue to use it because it has some really important phrases in it, and it's often called the three-legged stool of sustainability. So if you leave with nothing else beyond we're all in this together, just think about three-legged stool for sustainability, because sustainability is all about balance, right? And we often talk about the balance between environmental stewardship, social well-being, and economic vitality to meet our present needs while ensuring the ability of future generations to meet their needs, right? So there's that temporal aspect again, but it's about balance. And it's not always saying the environment's important. As I said at the beginning, sustainability is really about people. It's really about us. And then at the University of New Hampshire, we took this one step further and came up with this definition. At its core, sustainability is a collective commitment to human dignity for all people and ecological integrity of all the places that support us. And I would say that is the big picture of sustainability. I want to just talk a little bit about sort of how we might pursue sustainability at universities. And this comes from a paper that my colleague Vanessa Levesque, who's now at University of Southern Maine, and I wrote back in 2021. And what we did was it was a year-long process. We had a sustainability fellow help us. We looked at what universities across the country were doing for sustainable education goals. And we had a year-long process where we interviewed faculty, staff, and students at UNH. We had lots of focus groups. And we were able to whittle down sustainable education goals into 4 items, which I was actually really impressed with, right? First of all, we have to comprehend grand challenges. Think about those sustainable development goals. There's other grand challenges, but that's a good place to start. We need to think in systems. We need to think about the interconnectedness of the environment and our economy and social systems, right? They do not act in isolation. They are connected. We have to understand how those systems work, and we have to be able to scale between thinking about those systems at a very small scale all the way up to the globe, and if you enjoyed the eclipse, right, indeed our solar system. Really important to advocate for values, so it's really important for students to understand that there's different ways of knowing, there's different ways of thinking, there's different ways of acting, and that we appreciate and respect and learn about those, as opposed to thinking that our value set is the only value set that's important. And then finally, and perhaps most importantly, is really to apply this knowledge to a lifetime of action, both in your personal life, in your professional life, and in the communities that you live in. So if you want to learn more about what we think, I can always read the paper. You can shoot me an email. I'd be happy to have a cup of coffee and talk about it. I read this word today. The first time I've ever seen it, it said, well, that's unsustainable. Sorry, it's not the first time, but in the way it was used, it's unsustainable practice. And so this is, I should have had that, right? This is not sustainability, right? But this, I think, is how you could define how we have organized many of our professions and many of our disciplines. It's like, you need to be very good at something very narrow, and don't worry about all that other stuff, right? Don't worry about the big picture. Just worry about your little lane. And that's exactly, and sustainability is exactly the opposite, right? We have to embrace the big picture. It doesn't mean you become excellent in a discipline, or you don't dive deep, or you don't stare down a microscope and learn something. But at some points, it's important to step back and see how what you're doing, what you're studying, relates to the much bigger whole. All right, that's on sustainability. Now we're going to move to the climate crisis. Climate scientists, I think, have been criticized for decades at not being able to clearly communicate the challenge. So here it is in 12 words. It's real, it's us. Scientists agree, it's bad, we can fix it. And I'm going to finish up today talking about why I'm actually particularly optimistic about how we can fix it. A little bit of shorthand, I think, in terms of the way we fix it, right? We need to electrify everything. We need to electrify our thermal loads, and we need to ensure that it's renewable energy that's supporting our electrical grid. There's a beautiful picture of the Alphon Forum with a new 300 plus kilowatt solar array on it. You can see that really beautiful picture of my Toyota Tacoma and all the insulation that I've had, because efficiency is really, really important. And it turns out that it's hard to find a good image of efficiency, so that's mine. And then natural solutions are really important. So thanks Will Kaczynski and his class for this drone shot of campus. But those natural solutions, the barrier islands, the forests, right, the salt marshes are really important for providing us with so many key services, and part of that is resilience to climate change. All right, so how did we get here? Well, I started off talking about how we've burned our way into this problem. So here's emissions of carbon dioxide from around the globe from one of my favorite websites, actually, The World in Data. 1900 up to 2022, the different colors represent different countries or different regions of the world. A couple things that are really important here. If you look at the European Union at the bottom in the brown and the peach, and then the United States, you can see around 1980 we started flattening out our emissions. That's good, right? We started, and a lot of that was because we actually switched to natural gas. Then you can look up, you can see the entire continent of Africa, right? See that little green? right? Very few emissions coming from Africa, huge population, which clearly indicates to me that it's not solely a population problem, right? And then look at China, right? Post-2000, the emissions from China just explode. But what's encouraging is that they're beginning to flatten out. Then you've got the rest of Asia, then you've got some other sources. So really steep growth from about 1950 up to about 2010. I just want to blow this up a little bit because that's not the whole story. And this is an image that's just going from 1990 to 2020, which is all anthropogenic emissions. So that graph I just showed you is what's in the black, the fossil carbon dioxide, right? And we're about 37 to 38 gigatons, which is 1 billion tons of carbon dioxide into the atmosphere every year. From our industrial agricultural systems, we've got methane and nitrous oxide. So that's a CH4 and N2O. That little orange line is fluorinated gases. And then the green at the top is land use cover, and forestry carbon dioxide. So we have emissions that come from the agricultural systems, and then we also have emissions that come from the way that we use the land. So I just want to go back and forth. I just want to go back and forth. You can see there's this really rapid growth, right, up until about 2010. If you look at this next figure, it looks like we're still growing really quickly, but in fact, we've done a really good job at leveling out emissions. Just let me go back. If you look just at the top there, you can see we're beginning to flatten out. You might not think that's a big deal, but back in the 1990s, we had no idea how we were going to slow emissions of greenhouse gases, and in 20 to 30 years, we figured it out. We're flattening out. That's really good. And even China is beginning to flatten out. India is going to be a really big challenge there. So, one success story. We're flattening out that curve. I wanted to put this up because it really speaks to some moral dimensions of this challenge. And that the carbon dioxide that I emitted when I drove up to UNE today is going to be in the atmosphere for hundreds of years. That means it's cumulative, like it's a bank account that you put money into that you never take money out of. There's a carbon cycle and carbon cycle lot, but really, the carbon dioxide we're adding that's extra is staying up there for hundreds of years. So when you think it's important to think about the cumulative impact on the atmosphere by different countries, and you can see that United States, we're number one, right? Bigger than anybody else in terms of cumulative emissions. We're up close to about 450 gigatons of carbon dioxide. And I would argue, and the European Union is close behind. So people say, well, China's the biggest emitter today. They are today, but historically, most of the carbon dioxide has come from the Western world. And I would argue that that makes it our moral responsibility to lead on this problem. We need to figure it out now, and we need to allow countries like India and Indonesia and Brazil that have emerging economies to figure out how to reduce their emissions a little bit longer. We need to give them a little bit of grace and a little bit more time, but we need to act. It's really important for the Western world to act on this issue. And as a result of all that fossil fuel that we're burning, carbon dioxide in the atmosphere is rising. This is probably the most famous environmental record that we have, carbon dioxide from Mauna Loa. You see the long-term increase. When I was born in 1961, right, 320 parts per million by volume. We're now up to 420 parts per million by volume. I'm not going to go into the physics of greenhouse gases, but it's the same. Greenhouse gases are the same thing as putting a blanket on your bed on a cold winter's Maine night. That blanket traps long-wave radiation coming from your body. Carbon dioxide traps long-wave radiation coming from the earth and causes the system to heat up. All right, so more carbon dioxide, trapping more of that long-wave radiation, right? The planet is warming. And you can see that monotonic warming has really started since about the late 1970s. It's just gotten warmer and warmer, and 23 of the 24 warmest years have occurred since the year 2000. The one warm year before that was 1997, and that was an El Nino. But the trend is clear. Right now we're up approximately 1.2 degrees Celsius warmer than we were based on the long-term average from 1900 to 2000. All right. Not only that warming planet is causing our seas to rise, in part because warm water is less dense. I showed you those sea surface temperatures in the North Atlantic, but more importantly because Antarctica, West Antarctica especially, and Greenland are melting, and they're actually starting to, the big ice sheets are starting to collapse. So here we've got global mean sea level starting in 1993 when he put the satellites up. And in that first decade there, sea levels were rising 2.1 millimeters per year. The following decade, 3.3 millimeters per year. And now seas are rising at almost 4.8 millimeters per year. So we've seen a doubling in the rate of sea level rise, right, over the last 3 to 4 decades. And one of the big uncertainties in the future of sea level rise is we do not know how fast Greenland and Antarctica are going to collapse. It's a system we have not viewed or studied before, but they could collapse relatively quickly or they could collapse relatively slowly. I can tell you this for sure. Sea levels are going up for hundreds and hundreds of years. It's something that we have to come to grips with and talk about. And there's the same good news, bad news. Bad news is sea levels are going up. Good news is it's not happening tomorrow, it's not happening next year. There's already damage happening because of our storms, but we have time to actually address this challenge if we choose to address it. All right, and then I wanted to, one of the things I said, it's us, right, in my 12 words. So this is probably one of the most famous graphs that I have sort of had the opportunity to be a part of constructing. And it really tracks, first of all, how temperatures have changed over the course of the past 2,000 years. This is from the Intergovernmental Panel on Climate Change. You can see, 1,000 years. We have this period back here around 1500 to 1850 called the Little Ice Age, and then you can see the warming, right? So it's warmer now than it's been in the last 2,000 years, and in fact, the warmest multi-century period in the last 100,000 years, right? So warmest period for the last 100,000 years. And then the question that science asked and asked sort of 30 years ago is, how do you know the warming is due to what human beings are doing? So we have these really powerful tools called global climate models, and we use those global climate models to run what-if experiments. And so we ran those models, just driving them with natural climate variability. Remember, climate changes, it always has and always will. So you run it over the time period of hundreds of years, really, solar forcing and volcanic eruptions are the main drivers. You cannot see the warming. That's the green line. The models show no warming as a result of natural variability within the climate system. Only when you input the human changes to the system, which include greenhouse gases, but we've also served to cool the planet by putting aerosols. When you put all that together, what you find is that our understanding of the warming is actually pretty good because the model outputs actually match the observed warming that we see in the instrumental record. It's us, right? Science has answered this question again and again and again. What does that warming mean? Well, I could do a whole talk just on what the impacts are going to be. I'm trying to capture this in one slide, sort of outside of sea level rise. So the sixth IPCC report came out and built upon what are called these burning ember diagrams. And they show something that is really important, and I hope this is a message that you can all take home with you, is that climate risks increase with every increment of warming. 1.5 degrees Celsius warming, right, is better than 1.6 degrees Celsius warming, is better than 1.7 degrees Celsius warming. And the challenge is going to be to reduce that warming as much as we possibly can. So if you look at the left-hand side of this, you can see the risk impact. The purple is very high, the red is high, the yellow is moderate, the white is undetectable. And then you can see the temperature going from 0 to 5 degrees centigrade, and you can see there's that 1.5 degrees centigrade line, dashed line. That's sort of what the Paris Agreement has suggested we should keep the warming to, right? And in this diagram, we're looking at land-based systems. So we're looking at wildfire damage, permafrost degradation, biodiversity loss, dryland water scarcity, tree mortality, and carbon loss. And what you see is, as you go up the temperature range, right, the risk and the impact move from being moderate to being high to being very high. Every increment of temperature results in an increase in climate risk. So I can just, I know this is a School of Marine and Environmental Program, so I didn't want to leave out the ocean coastal ecosystems, but one of my favorite environments, right, warm water corals, you can see already in a lot of trouble. Unlikely that we're going to be able to do a lot to preserve those. Might have already crossed that tipping point. For the rest of the ocean ecosystems, if we keep warming to 1.5 to 2 degrees centigrade, the impact is moderate. So there's a whole bunch of these burning ember diagrams that I could show you. I'm not going to belabor the point, but every increment of warming is important. And you can think about this as just relating to the every 1/10 of a degree Celsius means that hundreds of millions of more people suffer. All right, and because I'm at UNE, because I wanted to come to UNE, and a big part was because of the health professions that are so dominant here. And so there's clearly an impact of climate change on human health. This is a really complicated diagram, but what I want you to leave is that there's a myriad of ways that climate change is affecting human health. So if you look up there at the top at the severe weather, that blue figure, right, there's the direct impacts, like we've experienced in Maine, right? Three storms, another one coming on Saturday, direct impacts. But then you can think about how the air pollution associated with climate change results in asthma and enhanced cardiovascular disease. We're seeing changes in vector ecology. I've lived through dengue fever. I'm happy to say that. I was young and healthy. And now I've had Lyme disease twice, and I've had antibiotics to support myself. But that's the changes in vector-borne diseases are important and significant and likely going to increase. Increasing allergens. When you get warm air that has more carbon dioxide in it, you know what plants really do well? Weeds, especially ragweed. Way more ragweed pollen coming to an environment near you. It's going to increase allergies and asthma. Water quality impacts on food supply, especially in the tropics where it might be get too hot to grow their own food. Environmental degradation, extreme heat, back to severe weather, right? And then one of the emerging fields that's become really important is what are the mental health impacts? There's two that are highlighted here, right? Environmental degradation and severe weather. But I would argue that every one of these actually affects our mental health. And what is it that we are going to do about that? I think that's a really big open question. All right. I'm almost at the end of the bad news. The whole place just quieted down. There's also, and let me say that like 5 years ago, climate scientists weren't talking a lot about this. But now that people are understanding a little bit about climate change, it's really important that we highlight the broad range of risks. So not only are there key tipping points in the climate system, right, and there's 3 forms of tipping points. Really, there's the loss of ice sheets and sea ice. And by tipping points, I mean once it starts to change and you tip, it's really, really hard or impossible to get back. So that's happening in Greenland. It's happening in Antarctica. We're losing the Arctic sea ice. I've talked about those. There's loss of permafrost. As permafrost thaws, guess what happens? Put more carbon into the atmosphere, warms the environment, melts more permafrost, you put more carbon in the atmosphere. Permafrost scientists call this the carbon bomb, right? We want to make sure the permafrost stays permafrost. And then, you know, same is true potentially for really big ecosystems like the Amazon, and then changing in ocean circulation in the North Atlantic. What Lenton and colleagues identified in this paper was that these tipping points aren't isolated. They're actually connected. And so we could see a cascading set of impacts where one tipping point falls, and the next tipping point falls, and the next tipping point falls. And so I would argue, at the very least, what we need to do everything we can to ensure we don't cross these tipping points. And those burning ember diagrams don't do a great job at capturing what might happen if we cross these tipping points. I've already talked about surface albedo. So we're on to solutions now. Here's the uplifting part. So what are the carbon dioxide emission pathways that we need to follow in order to limit the amount of warming? Well, here they are. You've got the 1.5 degrees. If we want to keep warming to 1.5 degrees Celsius, we have to get to net carbon zero, the entire globe, by 2040. I would argue realistically, it's not going to happen. Don't see how we organize ourselves. We've waited too long. On the other hand, if you look at the red line, at the 2 degrees centigrade warming, right, net zero by 2080, by the way, each of these is a 50% chance that temperature doesn't go above that number. So it's not a guarantee, it's an estimate. And then you can see 1.7 in the middle. But this is why it's so important that we all, in our individual lives, our professional lives, and our communities, begin to figure out how it is we reduce emissions to get to net zero as quickly as possible, and hopefully by 2050, so that we limit global warming to less than 2 degrees Celsius. And if we can do it to 1.5, I will be thrilled. And then I would argue that climate change actually is the innovation opportunity of the 21st century. And not just innovation in sort of cool solar panels or solar technology or lithium-ion batteries, but really in the way we organize society to address challenges, because we have to work together. We have to collaborate. It can't be like the Democrats figuring this out and the Republicans not, or the conservatives figuring it out and the liberals not doing it. We all have to do it together. And there's really two big strategies that we talk about: mitigation and adaptation. So we have to reduce our greenhouse gas emissions, that's mitigation, and we have to adapt to the change that's already baked into the system. The most important adaptation strategy is mitigation, because it reduces the amount of climate change we have to adapt to, right? You cannot go down a pathway and say, yeah, let's not worry about fossil fuel emissions, we'll just adapt. Just go back to that burning embers diagram. Every 1/10 of a degree Celsius makes it harder to adapt to the changes that are coming. So we have to walk and chew gum at the same time, right? And then I would argue that we need this action by everybody, starting now, forever. So short and long term, individuals and families, we all need to engage in this. Not because as individuals we're going to solve this problem, but because as individuals we're going to learn that the problem can be solved. And then we're going to take that knowledge to whatever institutions we're in, whether we work in business and industry, whether we work in government, whether we work at nonprofits, faith-based organizations, or at universities. We're going to know how we do it. And we're going to know that we can do it, and it's going to save us money, and it gives us a better quality of life. So why isn't everybody doing it? And then we have to take that knowledge to our communities as well. And if there's one other message I hope, especially the students in the room, can take from today, is that if you want to get engaged beyond what you're doing already, volunteer for a board in your municipality. I've been doing it now in Kittery for 5 years, and I have learned so much about the way democracy works. You have to learn how to listen and compromise, because for some reason in municipalities, like, everybody's equal. Yo, Cam, doesn't matter you got a big Ph.D. I'm a fisherman, and I'm supporting my family, and they're right. So I've really engaged in those discussions, not as an expert, but as a member of that community. And then I actually stole this from our climate action plan in Kittery. I mentioned this at the beginning, right? 3 big efforts. If it's really complicated, just remember these. We need to electrify, we need to build climate resilience, and we need to become more efficient. All right, so after all that, why am I optimistic? And I am optimistic, and it's not just because I'm Canadian. There's key trends, there's this notion of exponential change, and there's this notion of leverage. Oops. All right, first of all, climate change in the American mind. You can see back there in 2008, that was before the big economic crash. Most people believed that climate change was happening and that it was caused by human beings. But you can see a big drop down to 2010. But since then, it's been climbing, right? So we're solidly up at 72 to 73% of people in the United States believe that climate change is happening, which means we have a critical mass to address this challenge, right? This is a really important trend. At 50%, it's really hard. All right, I'm going to show this video by David Suzuki that talks a little bit about exponential change. It's a little bit frightening, but then I'll talk to you about exponential change can go both ways.
Our home, the biosphere, is finite and fixed. It can't grow. And if the economy is a part of and utterly dependent on the biosphere, the attempt to maintain endless growth is an impossibility. Let me show you why. Steady growth over time, whether it's the amount of garbage you make, the size of your city, the population of the world, anything growing steadily is called exponential growth. And anything growing exponentially has a predictable doubling time. I am going to give you a system analogous to the planet. It's a test tube full of food for bacteria. So the test tube and food is the planet, and the bacteria are us. I'm going to add 1 bacterial cell to the test tube, and it's going to begin to divide every minute. That's exponential growth. So at the beginning, there's 1 cell. 1 minute, there are 2. 2 minutes, there are 4. 3 minutes, there are 8. That's exponential growth. And at 60 minutes, the test tube is completely packed with bacteria, and there's no food left. So we have a 60-minute growth cycle. When is the test tube half full? And of course, the answer is at 59 minutes. 59 minutes, it's only half full, but 1 minute later, it's completely full. So at 58 minutes, it's 25% full. 57 minutes, it's 12.5% full. At 55 minutes of a 60-minute cycle, it's 3% full. So let's suppose at 55 minutes, one of the bacteria says, hey guys, I've been thinking we got a population problem. The other bacteria would say, Jack, what the hell have you been smoking? 97% of the test tube's empty and we've been around for 55 minutes. They'd be 5 minutes away from filling it. So bacteria are no smarter than people. At 59 minutes, they go, oh my God, Jack is right. We got 1 minute left. What are we going to do now? Well, we better give that money to those scientists. Maybe they can pull us out of this. But the world for the bacteria is a test tube and food. How can they possibly add any more food or space to that world? They can't. They can no more add food or space than we can add air, water, soil, or biodiversity to the biosphere. This is not speculation or hypothesis. It is straight mathematical certainty. And every scientist I have talked to agrees with me. We're already past the 59th minute. So all the demand for relentless growth is a call to accelerate down what is a suicidal path. And by focusing on growth, we fail to ask the important questions, like, how much is enough? Are there no limits? Are we happier with all this stuff? What is an economy for? We never ask those questions.
I would put it, what is the good life, right? I think it's really important to have those conversations. And I show you that not to scare you, but I show you that because exponential change can also work in the other direction. So what I'm showing you here, this is really one of my favorite graphs. It's called the levelized cost of energy. So it's the cost of energy to build the power generating station, to operate it, to pay for the fuel, and to decommission it. So it's the lifetime cost of however you're generating the energy. And on the bottom here, you can see we're going from 2010 to 2020. I've got bioenergy, geothermal, and hydropower. In terms of dollars per kilowatt hour adjusted for inflation, they haven't changed much, right? They're about 5 cents per kilowatt hour. Haven't changed much. And then you can see in the gray is the lower end of fossil fuels and the higher end of fossil fuels. So what I really want you to focus on is the orange line in solar photovoltaic, right? So what we see is not exponential growth, but we see exponential decay in the price of photovoltaic systems. These are large systems. These aren't the ones we put on our house. These are large sort of utility scale photovoltaic systems. And you can see that solar photovoltaic are now at the very bottom of the price range for fossil fuels. If you look at onshore wind, it's less expensive than fossil fuels, right? So we now have a technology that actually can replace the burning of fossil fuels. The big challenge is going to be batteries, right? We have to figure out how to store that. That's where we're going to need a lot of innovation, but we can generate the energy without putting carbon dioxide into the atmosphere. That is an exponential decay that makes me really optimistic. We have the tools to solve the problem. We've also, for 30 years, for 25 years, I was convinced that all I had to do was talk to my senators and representatives and we would solve this problem. Right, Sean? I mean, I don't know how many times I flew. I got good at flying down to Washington, D.C. and back in the same day. I had to do it so often. And, people listened. And then in 2010, we had Waxman Markey, right? Obama was president. And, it was so deflating when it didn't pass. And so I actually stopped doing it. I said, I'm just going to work on local and regional issues. I can't do this federal thing anymore. Nothing's ever going to happen. And others picked up the ball. And Biden passed the bipartisan infrastructure law. That was really good. But then the Inflation Reduction Act, which is really our climate change bill, right? So within the space of a year, we have almost $1.8 trillion to focus on this clean energy transition, right? And what's really important is that this is a major investment in supporting the U.S. commitment to reduce greenhouse gas emissions 50 to 52% below 2005 levels. And I can tell you beyond a shadow of a doubt that the passage of the Inflation Reduction Act was driven in large part by youth in this country. And one of the groups was the Sunrise Movement. And and Alexandra Octavia Cortez, if I said her name right, AOC. But it was, like, my generation did not have the political will to make this happen, but when we added the youth, we were able to get it over the line, and I'm thrilled that Bernie Sanders is going to come speak at commencement, because he was front and center in the development of that Green New Deal that ended up, was gutted by a senator, but ended up in this Inflation Reduction Act. So this was something that the scientific community was hoping for and working for, and the climate advocacy community for 30 years, and we finally got it, and it's a big deal. Big question is it working? Let's look at US clean energy investment by quarter, right? So we're going from 2018 to 2023. Each one of those blocks is a quarter, and you can see from 2018 to 2023, that is not linear growth. That is exponential growth, right? Investment in clean energy. By the way, this is my favorite new source of information is from this group called the Rhodium Group that does these cool analyses. So a lot of the slides come from them. You can look at this big question is, did Bill and IRA, infrastructure law and the Inflation Reduction Act, catalyze investment in clean energy? So this is fiscal year 2023, billions of US dollars. Federal investment was $34 billion. Private investment, $220 billion. The bill is doing exactly what the authors wanted it to do, is it's bringing investment from other, let's say, dirty energy into the clean energy realm at a leverage of 5 to 6 to 1, right? It's doing a really good job at sending a signal that clean energy is where we need to go, and that's where you should put your dollars, and that's where you're going to make the most money. One of the challenges, I would say, has been in developing renewable energy. So here's a gigawatt of net summer capacity added. We focused on summer because that's when it turns out that our peak load is now. From 2018 up to 2023, you can see the yellow in solar has been doing pretty well, but there was a bit of a hiccup back here in 2022. Supply chains, interest rates, when you're working on these really big renewable projects, they have a really long horizon. And there is sort of some NIMBY not in my backyard that's affecting them as well. So this is not on pace to reach the goals set out by the Inflation Reduction Act. It's not horrible, but we need to do better moving forward. And then you've heard a lot of news about how, oh, you know, EV sales are way down. Well, turns out that they're not. When you look at what the projections of what the Inflation Reduction Act would do in terms of EV sales, the Rhodium Group thought it would be somewhere between 8.1 and 9.4 of sales by the time we got to 2023, and we're right at 9.2. And I have to tell you, like, at 9 to 10%, right, we've got sufficient market penetration for this to make a really, really big difference. And if you don't believe in EVs, just go talk to somebody who drives one. I know Will has one. I know Sean has one. I know Ruth has one. Ask them. They love them. They're fun to drive. As soon as my hybrid Prius no longer runs. And then there was just this report that came out from BlackRock on the cost of lithium-ion battery costs, right? Noticing a trend in sort of exponential decay in cost, right? Back when I bought my Prius, even before this, the battery was really expensive. It's much less expensive now. And now there's a whole new set of technologies, different technologies that are coming out for batteries. So lithium ion is really important for cars, but we need to really figure out grid scale storage for electricity. And that's going to happen in the not too distant future. BlackRock went so far as to say the transition to a low carbon economy is set to spur a massive reallocation of capital as energy systems are rewired. If you don't know who BlackRock is, they're the largest investment firm in the world, right? These are people who are making money for other people through investments, and they see this huge potential in the clean energy sector. Clean energy, electrification, and what really shocked me was climate resilience. They're beginning to see that actually helping homeowners and municipalities become resilient to climate change is a growth area for the economy. This is all really encouraging to me. The notion of lithium-ion batteries, though, brings up a really important aspect about environmental justice, right? We know that a lot of our critical minerals are coming from places where people are either slave labor or being paid very low wages to work in very dangerous jobs to afford us the lifestyle where we have EVs and cell phones. And so I think this is a particularly interesting discussion for the state of Maine because we've just discovered likely the single largest lithium mine in the world. Right? Outside of Newry, it's called Plumbago North. That's a picture of a longtime mineralogist from western Maine standing next to a huge spodumene crystal, which is a lithium crystal. And so there's a big debate going on now is should we allow the mining of this lithium? And it's a moral question for me in that, well, if we don't allow it to happen in Maine and have the regulations to ensure that it's done properly, then we're going to be getting our lithium from the Congo or we're going to be getting it from China. It's a conversation that's really important and one that we need to have and speaks directly to the environmental justice issues that we have to address. I'd be remiss if I didn't talk about the wonderful work that Maine Won't Wait, which is Maine's Climate Action Plan, is doing, but this is their sort of their dashboard for 2023. I just want to highlight that upper left-hand corner, right? 115 plus new air source heat pumps installed since 2019. If you had asked anybody in 2015 if you thought we could do that, they would have said, not going to happen. It's impossible. They don't work in Maine. And now we're looking at getting 275, so well over 30% of all the homes in Maine with air source heat pumps by 2027. It's a huge success story. If I had all the numbers for every year, you'd see this incredible exponential growth. We've had them for 10 years in our house, and we love them. We also see significant action happening on municipalities. I've been really happy to chair the Kittery Climate Adaptation Committee. We've just minted our climate action plan in 2024. Biddeford has done theirs. They passed it in October 23. I just heard Pam Morgan's here somewhere. She's been working on the Kennebunkport Climate Action Plan. They just voted unanimously to pass it. Big round of applause. And Kennebunk is coming soon. All four of us did our climate action plans together, supported in no small part by the Southern Maine Planning and Development Commission and money from the Maine Won't Wait program. So really important that our municipalities and our regional entities are developing the capacity to address this challenge. I'm not going to talk about UNH because I'm running out of time. I want to talk a little bit about like my home and what I've been doing because I encouraged you all to do personal action. So there's my little duplex in Kittery. You see we got solar panels on the roof. We did that when we had a little windfall. We installed air source heat pumps. This truck here, beautiful stainless steel truck, delivers the wood pellets to my house. They get pumped into a big hopper in the basement. They get vacuumed in to my pellet boiler. So I heat my hot water on both sides of my house on the coldest days with wood pellets. I don't have to carry any bags around. And actually, because of these investments and because wood pellets cost much less than oil, I should mention the day that oil tank got taken out of my basement was really one of the greatest days of my life. Like, does anybody go in the basement and say, I love the smell of oil? I got a air source water heat pump there as well. But we're really able to provide affordable housing in our duplex because we've installed all this renewable energy, and we actually provide energy with our apartment as well. Last but not least, I really want to talk just a little bit about youth leadership. And can anybody identify that woman in the middle of that picture? It's Greta. So Greta Thunberg is an example of one of so many youth that are making such a difference on climate change. However, that's not really why I'm showing you this picture. I'm showing you this picture because the woman on the right is my niece, Carolyn Aubrey Wake, who's also a glaciologist. Just got a job at Lethbridge University in a tenure track position. And she is so sophisticated and knows more about climate change than I do at the early stage in her career. It's why I have hope, is because the youth of today are actually much better educated and they want to drive change. So more than anything, the technology is great, the investment's great. I'll finish up by saying we're all in this together. We need to figure out how we all work together and solve this problem. And I'd be happy to answer any questions. This is my last slide to say don't forget to take the time to smell the roses. This is my eclipse picture up at the Haida Land in Maine. If you want to go fast, go alone. If you want to go far, go together. All right, we have a couple of microphones here. Happy to answer any questions, start a dialogue. We've got some, I left plenty of time for questions. Eclipse glasses. You're all still here. Yes, sir. Do you guys need the mic for the, yeah.
And that's the problem that we see is that the big banks, the biggest, four dirtiest banks, continue to bankroll big projects. And the LNG projects in this country that were temporarily, some of them on hold, 10 are going forward. I've seen figures from the Sierra Club of equivalent of 358 new coal plants. So I hate to say I'm not that optimistic because, who was it? Jamie Dimon just a couple years ago said to the congressman, basically, screw you. We are in it to make these profits. We are going right ahead with funding these new programs. So how do we offset the banks and go against the banks? That's what we're all about. And just one last thing. All the young kids, usually at the universities, one of the things they get right away is a credit card offer. And I'd like to ask, what credit card are we offering here on this campus, if any? I hope it's not one of the big banks. I hope it's a local Maine bank that does not invest in fossil fuels.
So there's a lot in there. Thank you. First of all, I don't know of any investor who would want to put their money into a coal-fired power plant in this country, right? They're too expensive. There's lots of problems. And in fact, my colleagues from the Conservation Law Foundation are here. Decades-long work at getting rid of coal-fired power plants in New England, and we just closed the last one, right? Big deal. I think it's important, to your point, I think it's really important on where we think about investing our money, and we should not be investing our money in those entities that are investing it in things we don't want. So the thing I say is interrogate your investments. Not only should you get a reasonable rate of return, but you should be investing money in solving the problems, not in creating the problems. And I think when we do that, so the credit card's a great example, but across the board, right? Invest your money in the world you want, not in the one that's solely going to make you money. And right, the UNE fund is doing that already. The other part of it that I don't think like a lot of investors have got the memo is fossil fuels now carry substantial risk because they are going to get sued like the tobacco companies got sued. And it's only beginning. Thank you, youth in America, for getting this started, by the way. And so people, like when you talk to investors, they always talk about risk. Fossil fuels are now risky. Solar PV, like there's no moving parts. You put it up, and it works for 25 years, and people make money. So I think it's the market is going to, and you're beginning to see the money move over, and Jamie Dimon is going to be right behind it. He's going to follow the money. I am Canadian and optimistic. Two questions right in the middle.
At the beginning of your talk, oh yeah, my name is Marin. I'm a junior marine bio major here. At the beginning of your talk, you were talking about how education is hugely important for developing more sustainable lifestyles, and I agree with you completely. However, unfortunately, especially in the United States, there's a huge disparity in quality of education depending on socioeconomic status. So how do you think that we as a society should tackle that so that people from all backgrounds can get quality education in being sustainable?
Excellent question. Thank you for that. I'll say I do not have all the answers, but I think I just got on my phone today a notice that Joe Biden has just canceled the debt for another sort of set of people, in tens of billions of dollars. So that should help them. I really think we have to think about how the whole entire education system works. And for those families that can't afford to send their children to college, I think we have to invest in the community college system. And I think that makes a lot of sense to me. So I grew up in Canada, grew up in Quebec, and so I graduated school at grade 11, and I went to CEGEP for 2 years for free, paid for by the government. And what was really nice was it was a time like I could find myself, away from home for the first time. There was a lot of stuff going on. And so I think that investing in the community college system and really valuing that education. And then I really think we just have to do a much better job at the trades. Like as we electrify, we're going to need way more tradespeople. And I've built enough houses in my life. Like I really love working with tradespeople. And they have a set of skills and they're really smart. And this notion like if you go to school, you're smarter than somebody else. Like, yeah, I don't think so. It's that different people have different grooves that they're in. So community college and trades would be my answer.
I feel like another aspect that we focus less on is methane. It's a multitude times more potent than carbon dioxide and has a much shorter lifespan. So it means that if we stop using it, it'll dissipate faster and make a very big difference. One of the main sources for that is agriculture. And we don't necessarily, we're developing, alternatives for beef, like Impossible and things like that. But there's a lot of resistance, just like with fossil fuels, in reducing our meat consumption, especially beef is a very large industry. So how do we encourage, and that one can be a personal decision, but not everyone is going to choose to make that, which I get. So how do we also address climate change from other angles and solutions, such as addressing methane and in agriculture and other sources?
Excellent question. What was your name?
Oh, Finn.
And? What's your?
I'm a freshman and I'm a biology major.
Thank you, Finn. So excellent question. And I would say it's probably the single most rapid thing you can do to reduce your greenhouse gas footprint is to change your diet. And I don't think we should be saying you can't eat meat and you can't eat red meat. But I'll say 15 years ago, my wife and I decided that we were going to become flexitarian. We were going to eat a lot less meat, and we were going to source it locally. And what's happened, like it's a win-win. Like red meat is not that good for you, so you eat less of it, you're healthier, but we really enjoy it when we do eat it. So I think the answer is if everybody should be eating a climate-friendly diet. And it really starts with less beef at the top of that list. And local. Well, the methane is coming from the beef. And burps. Let's all compost. 100% of your food should be composted. Just do it now.
So my name is Tyler, and I'm a senior marine science student. I kind of have two questions. So I'm pretty sure I'm not the only person that has like family members or people that kind of aren't taking climate change seriously, and they think that it's not their problem. They don't think it's really real. So how do I like light a fire under them and kind of like tell them that this is actually happening, this is true, and we need to fix this? So I don't know like kind of tips you have, because I've tried to like have these talks and they don't really go too well, and it's frustrating for me. Because I'm going off into grad school and trying to like mitigate these risks and potential hazards that we have, and they're just not seeing it as like a problem. So like what could you say for me to tell them?
Do not light them on fire. So first of all, appreciate you trying. The thing about family is they're there for life, right? And so I think the most important thing is to take a really long-term approach to this. And I am sure that you have shared values with those family members, even though there's things you don't agree on. And so where is it that you can find that shared value where you can begin to make a difference? And so I did this not with a family member, but with a a very angry Republican in the state of New Hampshire that I sat on a commission with for 3 years. And he sort of accused me of lying all the time, and it was a long story. But we had to be in these meetings together, and what we realized was we had a shared love of New Hampshire's seacoast. And that is sort of where I backed up enough where I could talk to him about how he loved taking his grandkids to Hampton Beach. And by the end of the process, he didn't say Cam's a liar. What he said was, I don't believe the climate science, which was fine with me, because I went over and said, I don't believe the climate science either. I've examined the facts, and I know what the truth is. So I think take the long view and really do it with love.
And then I have another question as well. So going into grad school and trying to focus on like management and like of these ecosystems that are the most threatened, what other kind of like things can we do to try and mitigate the risks? And I know that like electrifying is one of the things that you said a lot, but that can be expensive for a lot of people. And as a broke college student, I cannot afford an electric car. So what other things can I do moving forward into grad school to try and better what is already threatened?
You said, what was your major again?
Marine science.
Yeah, so I think that there's, and Pam Morgan, I'll say Pam Morgan again, she's wonderful at this, but there's this whole effort that we really need to invest much more in natural solutions. And I don't think that we're training enough of our students to do that. So this is not going to be so much on the mitigation, reducing greenhouse gas emissions side, but on the adapting to climate change. You know, people are talking a lot about carbon capture and sequestration, and it turns out that there's this 3 billion-year-old process plus called photosynthesis that is really good at taking carbon dioxide out of the atmosphere. And all you need to do is like plant trees or maintain our salt marshes. And so natural systems can help solve, they don't reduce emissions, but they can take more greenhouse gases out. But they also can really, they provide us with a whole bunch of key ecosystem services. But really importantly, they can protect us from natural disasters as well. And again, salt marshes here in coastal Maine is really important. It's going to be a huge challenge to preserve those. And so I think working on ecosystems and preserving the amazing services that they provide us would be front and center. Like, I actually kind of wish I was an ecosystem scientist, but I was an ice core guy.
So this should be the last question. I hate to do this. This is a fantastic conversation, but it's the last question, and then we're going to let everyone get to their 2 o'clock classes.
Somebody's bringing the mic over.
So one of the biggest pushbacks I see of moving into more green energy is, what are we going to do in impoverished areas like West Virginia, where people rely very, very heavily on fossil fuels for their income, and they would have to go really into poverty without these jobs. What can we do to push green energy into these areas, making sure that these people are employed? How do we encourage that? How do we keep people in well-paying jobs while switching to green energy?
Excellent question. The first thing I would say is this framework of nothing about us without us. We should not be going in and telling them what to do. We should be encouraging them to move off of the mining of coal. And I think it's also really important to identify, especially with the coal mining and especially in West Virginia, it's really bad for their health, right? And we know that the mining companies have, for decades, disregarded the miners' health. Despite that, they need to be treated with respect. And so I don't think you have a government program that goes in and says, hey, you guys should all learn this. I think it requires that long community work of saying, what is it that we're going to do to transition off of coal mining and do something else? It needs to be their decision. And so I don't think there's an easy answer there. The flippant side of me, maybe I can finish with a laugh, it's like, hey, grow cannabis. Seems to be working in Maine.
Thanks to everyone for coming.